Hi, everybody. It's a cold and rainy day here in Williamsburg, and I'm here to talk to you about migration studies. You probably are wondering, how in the world did we learn everything we learned about bird migration? Well, there are 5 different standard ways that we learned initially most everything that we learned. First of all is banding. Banding involves putting an identification ring around the ankle of a bird, and every ring has its unique number. Why do we band? What does it provide us? Well, we learn, first of all, where these birds are going and where they're coming from. We get a general idea of where they're going. But in order for us to be able to get that information, we have to catch them again. And the rates for catching these birds a second time is somewhere in the range of 1 to 10%. It all depends on the species. Sometimes we don't catch very many of them again, but we've done so much banding over the years that we have a pretty good idea of where they're coming from and where they're going. It also gives us some idea of their behavior. We can learn their lifespan. For example, we used to take a trip over to the Eastern Shore to catch woodcocks, a game bird. And one of the woodcocks that we caught was shot and killed by a Frenchman up in Quebec. And it turned out at that time to be the oldest known woodcock. And we would never have known that if it wasn't for the band that was on him that maybe one of our students actually placed on it. So we also get an idea of survival of these birds. And when we catch them, sometimes we can take samples from them, and researchers can find out, do they have any toxins in their body? Are they suffering from any diseases? And it gives us an idea of the population, and that's how we establish hunting regulations every year. For example, every year the number of ducks that are able to be harvested changes from year to year depending on the population. So that's another useful number we can get from banding. A second method we use is telemetry. Now, telemetry used to be radio telemetry, where you would put a transponder on the back of a bird, typically a large bird because transponders weren't small, and then we track them with a radio receiver. But now, because of technology, we can actually put much smaller devices on birds, even on songbirds, and track them by satellite. And that has an advantage because it allows us to see everywhere they go. Whereas with banding, you just know where they were banded and where they were caught. But with this, you can track this bird everywhere it goes, utilizing this satellite telemetry. So this is some examples of some of the results you can get. This is showing a bird in Europe that is flying and showing all the different routes that this bird flew. Radar is another useful thing. We didn't realize radar could be useful until a gentleman was looking at a radar image and said, "Oh, what is all this stuff we see on this Doppler radar?" And the technician said, "Oh, I think it's just ground clutter." Well, it turned out to be birds migrating. And this is an image of birds leaving, I believe, leaving Cuba and heading north. And here's another image of Doppler radar. You can see all the different images showing up of birds starting to migrate. So it was a pretty useful thing to discover that Doppler radar could actually do that. Probably the oldest method is visually just watching. And so we have these hawk watch stations that are scattered throughout the US, and they turn their information to a central organization, and they sit and they watch these birds and record what they see. And then we have indirect methods, and the oldest of all these methods is the Christmas bird count that was developed over 100 years ago. It was started as a counter to all the birds that were being shot at Christmas time, because they used to have these Christmas hunts. And so somebody said, well, why don't we go out and count birds at Christmas instead of going out and shooting them? And so that began the Christmas bird count. Now, the Christmas bird count is considered an indirect method, mainly because there is no strict protocol. The only protocol is that you use the same day every year and that you're doing the same area whenever you do it. And that gives some kind of structure to it, but that's about it. So the manpower, though, and the area that you cover and the time you spend counting could be different from year to year. It all depends on how many people are able to cover a given area. Now we can look at 3 of these techniques at work at a place over on the Eastern Shore called the Kiptopeke Bird Banding Station, which is in Kiptopeke State Park. And it's a banding station that's operated by the Coastal Virginia Wildlife Observatory. So why have it there? Why at Kiptopeke? Why not in Williamsburg? Why go to the Eastern Shore? Well, as birds start to migrate in the fall, they're going to follow the prevailing winds, and those prevailing winds will lead them in a easterly direction. And birds that have migrated before will get to the Appalachian Mountains and they'll start moving down the Appalachians. But birds that are migrating for the first time, and there's a lot of them, what'll happen is they'll get to the water and say, holy cow, and they'll turn right. And as they turn right, they'll come down the coastline. And when they come down the Eastern Shore, if you notice the Delmarva Peninsula here, you'll see that it forms kind of a funnel. So all these birds will be concentrated down at the tip of the Eastern Shore, which is where Kiptopeke is. So if we kind of zoom in here, you can get a little closer and you can get a little closer. And this is Kiptopeke State Park. It's at a place where there actually used to be a ferry that came across from Norfolk before they built the Chesapeake Bay Bridge Tunnel. But it's one of the few places that have really good habitat. So basically these birds are flying south and they get to this water and they get down here to the tip of the Eastern Shore, and a lot of them stop to feed and put on some weight. And they put on a lot of weight. They'll put on, they'll increase their weight sometimes by 50% before they start to fly again. So when you walk up to it, here's what you'll see. This is the hawk watching platform, and here's the sign that you see below telling who runs it. And this is what the platform looks like on top. And you see all the people with spotting scopes, and they're all pointing north because they want to see the birds that are coming south. And they're going to count the birds coming south. And somewhere in there is one person, and the person at this particular year is Sam, and he's sitting right behind the scope. You can't see him, but he is the head counter. He's getting paid to count. And everybody else there is there just to help him and kind of point things out. There's also a Raptor Banding operation that happens right next to the hawk platform. And one of the jobs of the hawk counter is to let the bander know which direction hawks are flying from so that they might be able to lure them in, like this sharp-shinned hawk that they caught in a mist net. And there's a bird banding station there as well. They band songbirds that they catch in mist nets throughout the forest. There isn't a full-time operation there anymore. They lost their banding license a couple of years ago when they had some problems, and the USGS tightly monitors these operations to make sure that the bird's safety is taken care of. And so they pulled the permit, and they didn't ban songbirds for the longest time, but now the ODU is banding, and they ban sporadically. So let's look at each one of these activities that are taking place here. The Hawk Observation Platform, if you go there, you'll see that they keep track of all the data, what they saw yesterday, what they've seen to date, and what their peak numbers are. And there's some pretty high numbers there. So what does the hawk counter do? Well, obviously he identifies hawks and he counts them. But every hour he has to stop, he or she, I should say, they have to stop and they have to record hourly data, which of course includes the number of birds of each species he's seen, but also things that might affect whether the birds are migrating that day or not, like wind speed, wind direction, air temperature, visibility, precipitation, cloud cover, flight direction, altitude of flight, minutes observed, and how many observers are helping him. On peak days, he might have 10 people helping him. On slow days, he might be by himself. So when you see these birds flying, it's amazing to think of what he's able to do in terms of identifying. Now, you've already done a lesson on raptor identification. If you have, and you've paid any attention, you realize that there's some really good details that you could tell from these two birds because they're pretty close. You see that they have relatively long tails, that they have an M-shaped leading edge, but the difference between the two is that one has pointed wingtips and the other one has rounded wingtips. The bird at the front is a Cooper's hawk. The bird in the back is a falcon, maybe a merlin. But sometimes you get birds that are a little higher, and they're not as easy to see as those two were. And these turkey vultures, well, they look like they're hard to identify, but if you know a turkey vulture, you know that it has a dihedral shape. It's actually not too difficult to identify these guys from a distance. However, this could be a problem, not just figuring out what birds these are, but also how many there are. And I know that from this photo that someone took that there are over 300 birds in that picture. But a hawk watcher is trained to deal with those, and they are able to count those. All right, let's look at the raptor banding. So the raptor banding takes place in a field adjacent to the hawk platform. And at the top of the hill, there's a blind there where the hawk bander sits, and he waits for hawks to come flying. You'll notice that there's these strings coming out, and those strings coming out lead down to some to nets. They're triggers for nets, but some to bait birds that are sitting out there. Now you might say, "Oh, bait birds! Oh my God, they're using bait birds." Well, what they use are pigeons and starlings, and they use those first of all because they're not native birds. They're non-native invasive species, but they still look out after their safety. They actually have little leather harnesses that they wear around them to protect them, and that attaches to the strings so that what happens when they see a hawk coming, they can pull those string and the bird goes flapping up in the air, and the hawk says, "Oh my God, there's dinner," and down it comes. And what it doesn't know is that surrounding this bird are all these mist nets. And so you can see there's a starling in his little leather jacket there, just waiting for a raptor to come. And here's a raptor who came after him. This is, again, is that picture of that sharp-shinned hawk, and he's caught in the mist net. Now, sometimes they get past the mist nets, and if they do, there are these bow nets that are sitting around, and they'll just lure them towards the bow net with the bird, and then they'll set the bow net and trap them in the bow net. And when they catch them, then I know this seems kind of cruel, but they'll put them in different size cans, and what that does is it calms them down so that they don't hurt themselves. And it allows the bander to take all sorts of information and band them safely without the bird getting hurt. So they have different size cans for different size birds. The blue can there has a sharp-shinned hawk in it. The red can has a Cooper's hawk. And there is that sharp-shinned hawk again. And here, Mr. Williams is getting ready to release that hawk. They also have a songbird banding station, like I said. And they used to have large groups come by, and they would sit there and tell them all about what they were doing there and the different information they collected. So when is the best time of day to catch these birds? Well, it turns out that songbirds, the best time of day is early in the morning. Songbirds, when they migrate at night. And they migrate at night for two reasons. One is that there's not a lot of turbulence in the atmosphere at night. And the second reason is those large raptors that want to eat them don't fly at night. Those large raptors rely on hot air rising off the surface of the earth that was heated by the sun. And they use that rising hot air for lift. They don't have that at night, so they don't migrate at night. Now, after flying all night, and they may have flown several hundred miles in one night, they're pretty much spent when the sun comes up. So they fly down and they feed in the morning, and then they go and they roost for the rest of the day and rest up. And then they'll feed for several days before they end up moving on. They try to get their body fat up. So these mist nets are set up all through the forest to catch them as they're feeding in the forest. And when they catch them, they go out and they find them. They bring them back to this station to process. Uh, and this is the mist nets that they catch them in. These mist nets are hard for the birds to see, and they have little pockets in them. And so these little pockets will catch the birds. They'll fly into the mist net and fall into the little pocket. And you see a bird there, and then the bander will come by and get them. Then when they get them back to the station, the very first thing they'll do is put the band on it, because they don't want, if the bird were to escape, or if the bird was so stressed they felt like they had to turn it loose, they want to make sure they have a band on it. So there's all the different bands for the different sized birds that they might catch. And every one of those bands has a unique number on it. They'll measure things like the wing cord, which is from the shoulder all the way down to the tip of the wing. They might measure the tail length. And this is really an interesting one. They'll blow on the breast and blow the feathers away. And what they're looking at is the color of the breast. And that's going to tell them how healthy that bird is. Now, this one has used up all its body fat, so it looks really, really reddish there. But if it had a lot of body fat, it would look kind of a yellowish color. So we know that this bird hopefully is going to feed for the next 4 or 5 days before it flies again. And then there's this process they call sculling, which involves wetting the top of the head of the bird so they can see the skull underneath the feathers. And if that skull is not ossified, then that bird is what we call a hatch-year bird, or a bird that was born this year. If it has, then they call it an after-hatch-year bird, or a bird that's more than a year old. So you can see they can get all sorts of interesting information from the birds. And then after this, they release the bird. From start to finish, the process is probably no more than a minute and a half. They get really fast at it when they've been doing a lot of birds. So I hope you've enjoyed all of this. I know I enjoy birds tremendously, and I got into birds late in life, and it's been a passion of mine since I got involved with it. I've been able to help collect bird data occasionally. I collect it on my own and donate it to the Cornell Lab of Ornithology. You guys are young, so hopefully you can make some decisions and get exposed to this and decide, well, maybe this might be cool, and then you won't be like me, wishing that maybe I had done something different. So enjoy yourself, get out there and do some birding, see if you like it. Y'all take care.